All right, welcome back to AGI's video podcast. I'm Josh. With me, I have a few special guests today. We're back in our office and headquarters, and we have a new studio that we're trying out. So with me, I have two guys that I've known for a long time. They are applied physicists for space, John Carrico and Mike Loucks of Space Exploration Engineering. Welcome, guys.
Hey,
thanks for coming on.
Josh.
And you guys have done a lot of stuff for satellites, a lot of stuff in space. You were just telling me earlier that you have been a part of 42 operational satellite missions.
Yeah.
And a lot of those have been around the moon.
Yes. In or near or
interacted with.
Interacted.
On purpose, too? Yeah.
On purpose.
Yeah.
Most of them. Most of them,
crashed some stuff into the moon on purpose.
All right. Did you want to start off? I see you guys are both wearing your Laddie shirts today, which are pretty cool.
Sure.
And you always have a joke that you go along with that.
Yeah, a couple fun facts. I mean, you've heard about the restaurant on the moon.
Oh, yeah.
Yeah, great food, but no atmosphere. Right. So, one of the missions we worked on the moon is the Lunar, as it says on Mike's shirt there, Lunar Atmosphere and Dust Environment Explorer, or LADEE.
Right.
Yeah, and that was one where we did hit the moon on purpose.
There you go. Get a little closer to the mic.
Okay,
There we go.
Right, but
Perfect.
The mission was not a moon impact. That was just how we disposed of the spacecraft at the end.
When we were done.
Yeah.
Yeah.
So it was
So-
a lunar orbiter.
I think you
right.
were just saying your dent is right on here. You can see
You
it
can
right
see the
there.
dent right
See
there.
the
That's
dent?
where it hit.
that, that could be the
That's where you guys crashed.
Yeah.
Yeah, and that was a fun mission that had some challenges. So that was we were given a brand new rocket for that one, and so Mike actually got to help work on the upper stage and designing something so that they could have eventually a new commercial rocket that could take things to the moon.
Right. So we worked with Orbital Sciences Corporation and the guys out of Chandler, Arizona. We're designing a new upper stage around a solid motor that hadn't flown in that configuration before. So they had to build a whole stage around that. The lower four stages on there had all flown before in other configurations, but on the Minotaur 5 on Laddie, they put them all together, and so it was a stack of 5 solid rocket motors that put us on the way to the moon. And so that was a really interesting thing because of how solids work. So a solid rocket motor can't throttle like a liquid motor might be able to do. So instead of throttling or up or throttling down to get your final trajectory, the rocket actually has to either fishtail or porpoise, I think is the way we actually throttling. Fishtail this way, porpoise this way.
Yeah.
So that's how they bleed off energy and so that's a less precise way of controlling energy than a throttle would be. And so that gave us some interesting challenges in terms of the trajectory we had to design to deal with the different types of launch dispersions we might get, or the different orbit we would get than the one that we planned for.
Yeah, so we ended up going into these phasing loops. So we didn't do what, the Apollo astronauts, classically you think, okay, you launch from the Earth and you just, 3 days later you're at the moon. So we go into these highly elliptical phasing loops. And we've done this before. On Clementine was my first mission. We did phasing loops, and a bunch of other satellites that are deep space and need to time, you can phase. So if you launch earlier, if you launch late, if the rocket puts you in a slightly different orbit, and then you can make it all up in the.
So how long was that for you?
So the Laddie, I think, launched about
3 weeks.
Maybe 3 weeks before we got to the moon.
Yeah.
I think we launched on the September 6th and got to the moon on the October.
And then Bereshit just did something similar.
Bereshit did something similar, right? So.
No.
Yeah, the Israeli mission did a similar thing. They didn't launch to this. They launched to a GTO orbit, which was different because they were not the only spacecraft on the rocket. They had to there was a geo spacecraft that was going to geosynchronous orbit. That spacecraft was let off in the lower orbit, and the Bereshit mission, the spacecraft went to that orbit and then raised itself up with phasing orbits to get to the moon.
Yeah, they made an agreement for what orbit should you launch to that we both can get to where we want to go, and you're seeing that a lot more with these commercial spacecraft.
Right.
And so we launched into an orbit to go to GEO, and then we just hung around in that, kept doing maneuvers at perigee, pumping up the other side, and then again phasing for just perfect timing so that when we get to the moon's orbit, the moon's also there.
Right.
Which is good.
That's important.
Yeah,
right.
that's
Well,
important.
and phasing, people can get confused by what that is. If you just think it's really a waiting orbit, you go into an orbit, you wait there for a while, and you go up to another one and wait in that one for a little bit. And you have different levels that you go to, and each orbit has a different period associated with it. So when you launch, you're going to wait until the moon, comes around to where you are, and you have to wait, and you have to make the orbits that you're in add up to the amount of time that you have to wait. So it's a waiting orbit as opposed to anything
But it
more
gives you a lot more flexibility with getting there.
It does, because you can change the size of those orbits depending on what you're launched into, and as long as the total amount of time you spend at the end adds up to when the moon comes around, you're okay.
Yeah, and one of the things I'm excited about, for the waiting orbits, we're going to call them now, or the phasing orbits, is you also get a chance to commission your satellite, and you can get tons of tracking data. And we're now trying to track these things with other ground stations. So on Bereshit, we were just helping Israel with that, with helping Space IL. They used a completely commercial tracking system. They used Swedish Space Corps' USN, Universal Space Network.
And that whole mission was commercial, right?
Yeah.
So
Commercial software, commercial launch.
Yeah, and typically these kind of missions in the past done by governments use the big government assets. So like you might use a deep space network or the DSN dishes, which can be 70-meter dishes or 30-meter dishes, and the commercial folks at SSC have smaller dishes that are 13-meter or whatever.
And we had used them on the Laddie mission, so we knew they would work, but we weren't using them completely by themselves. So in particular, in this case, it's all commercial. And so what we had a chance to do is, while we're in these phasing orbits, also known as waiting orbits.
Waiting orbits.
Yes.
I get royalties every time you say that.
We could calibrate the tracking stations and really find out where we are. Because when you come into the moon, the goal is to get close but not hit, right?
Right.
Yeah.
Most of the time.
Yeah. And so I really like the phasing orbits for that as well. And
Very cool.
And if you're flying an engine that you haven't flown before, and you fire that engine and it doesn't quite work the way you want, you can have another maneuver to fix it with pretty much a 1-to-1 penalty. Where if you do what Apollo did, you have an error when you inject your translunar injection. It's like 10 times the fuel to correct for it 24 hours later. So phasing, we don't get paid by the phasing orbit lobby at all. So this is what we really think.
Right.
So speaking of the moon, a lot of people don't know that the moon's actually an acronym.
I did not know that.
Yeah. It's a massive object orbiting nearby. That's where that came from. Yeah.
Good.
Well, because they had already named, mostly a red sphere is where Mars came from.
Yeah.
So they had to come up with a good acronym for the moon.
What's Mercury?
No, not Mercury, but Earth is evidently a rare terrestrial habitat.
Very much.
Jokes from my brother Kevin Carrico.
Awesome. All right, so you guys just listed Clementine. You listed a couple other missions in there. Can you quickly go through all the missions that you guys, if you have time for it, all the moon missions that you were a part of?
Okay, so Clementine was my first operational mission. We called it the Deep Space Program Science Experiment at the time.
Okay.
So that was super cool because
DIPSY.
We got the contract in January of '92, and that's when we started working, and we launched in January of 1994. And it was really fast.
Oh, that is fast.
Yeah, and that was really cool. We spent 7 days in low Earth orbit, spun the thing up, and then went into phasing loops. Got to the moon, spent 2 months there, and then left the moon. And things didn't work out that well after we left the moon. We were supposed to go to an asteroid.
Oh, no.
The spacecraft had a mind of its own at that point.
Okay, so where is it now?
Yeah, so it's orbiting our sun.
Okay.
Yep. So it's happy there. Someday we'll go out and fetch it, bring it back to the Smithsonian, I hope. Yeah.
Nice.
So then after that, Mike, I think the next one you and I worked on was the WMAP program.
Right, yeah.
That was a gravity assist to the moon to get to the Earth-Sun libration point, the Earth-Sun L2 point, wasn't it?
I believe that's correct.
Yeah. And so we needed the moon's gravity to kind of shape it to a smaller orbit. So we were working with NASA Goddard and helping out there. And it's kind of the same thing where you really need to precisely, we're not going into orbit around the moon, but it's kind of the same thing. You want to get that distance of the way from the moon really precise.
It is the same problem if you're going into orbit. If you're flying by it, you are doing all the phasing. The moon has to be there at the right time, and it's when you come to capture, instead of capturing around the moon, you're just swinging by and going somewhere else. But all the build up and the phasing and the targeting and all that it's the same problem.
Yeah. And then let's see. After that was the next one, LCROSS, I think.
I think that was the one. Yeah, you worked LCROSS.
Yeah. So LCROSS is where we went out, got a gravity assist of the moon, then flew in somewhat similar to a backflip orbit, not quite, but this giant orbit that orbited the Earth-Moon system. Did that a couple times, and then came up under the moon and went into a crater. And that one was really fun.
So an intentional hard landing.
Well, there was actually two spacecraft. The one that came off of there was an upper stage. Actually, the whole mission launched the Lunar Reconnaissance Orbiter, and the LRO, as it were, went into orbit around the moon, and then the upper stage with LCROSS on it flew by the moon and did the trajectory John just described. And then when it came back, the LCROSS payload detached, and the stage crashed into the moon in front of it. It took a picture of that crash and then crashed behind it.
Then it crashed.
Oh, that's
it
cool.
had to take pictures of the dust with the sun behind it, beam those pictures, and the science data back
before it crashed.
Yeah. And one of the things that was funny about that, so that little LCROSS payload, we called that the shepherding spacecraft, because it's the thing controlling this giant Centaur upper stage, and we were getting ready to calculate that last maneuver. And we're working with the scientists, and we're looking at the moon and saying, okay, exactly where do we want to hit? They were getting updates from LRO to where's the most likely place to see water ice. So they finally picked a spot, and we have, one more maneuver to do final targeting, and then we're going to let go. The problem is when we let go, the springs are going to push. And so that's going to add a maneuver itself. So at first, we're like, oh, how are we going to do this? Well, let's just cant that, so when the springs push, they just change it in the direction of velocity and don't move it left or right.
Right.
But we had been calibrating the engines, and it's like, wow, this is a precise maneuver. We want it very precisely. But as soon as we let it go, and the springs have an uncertainty, and then we noticed that the springs were more certain than our engine was. And so what we decided to do is forget the last maneuver, and we just used the springs to push off in the right direction for doing the final targeting.
Oh, so you didn't even use the engine?
Yeah, we didn't. That last one, we didn't use the engine. It was a maneuver.
Now, how did you find out that the springs were more reliable?
Well, because as we're getting
test
ready,
those as you're flying, right?
Yeah, we tested the springs. We weren't able to test the springs. Well, we're just looking at all the specifications, and they give the uncertainties on these things, and we're like, wow, that's better than the engine. We can do a maneuver, an orbit maneuver with springs.
In order to do that, though, there's information you need to know about both of those things that you might not have readily available normally, right?
Yeah, so we did quite a bit of spreadsheet analysis. So they had a spreadsheet that had all the mass that was assigned to LCROSS and all the mass that was assigned to the upper stage. And so knowing the two masses and the spring constants, you could figure out the change in velocity, the delta V.
So here's the applied physics stuff going on.
So the applied physics comes on this, and we're looking through the list, and we're like, well, LCROSS is getting blamed for mass that's actually on the upper stage, like the big sticker that says LCROSS has mass to it, because they haven't invented massless stickers yet. I thought we had
to accommodate all that. So again, this is like your classic physics equation where you have the spring constant and you have the bodies either way, and you have to figure out what the velocities are going to be.
Yep.
So this is freshman physics again.
Yeah,
but you're having to figure out the mass of the
it was
sticker
the
and that
upper stage of the light band 2, I think it was, and so we just put the masses on the right side, took that spring constant, said this is our delta V, and then just we nailed her.
Nice, that's awesome.
Nailed her impact. That was one of my favorite maneuvers ever.
But you had to, in order for you to target correctly to hit the spot, you then had to turn the spacecraft all the right way so the spring constant did exactly what you wanted.
Yeah.
You couldn't change what the spring constant was going to do, but you could change the direction.
You could kind of bleed it off. You're kind of bleeding it off. Yeah, that was out at NASA Ames. Yeah.
And that really isn't much different than what we were talking about before on the Minotaur 5, where when you wanted to bleed off energy, you do the the fishtailing or porpoising.
Yeah.
It's the same kind of thing. Rather than burning along the velocity vector and only speed you up, you can kind of bleed it this way.
I think we might need more of a demonstration of the fishtail porpoise thing. Do you think one of you guys could do that?
Yeah, I think Mike can.
Maybe you could do that.
Pretty good at that.
I think I've seen you do it on the dance floor.
Yeah, exactly.
That's right.
He's trying to forget about it, but he might have seen it anyway.
You don't have that video anymore, right?
No, we got rid of it.
Yeah,
We're good.
after you paid, then he got rid of it.
I appreciate that.
That's how blackmail works.
That's
right.
That's right. Yeah, and so after LCROSS was the next one that we did. Was that Laddie?
I believe so.
Oh, no, IBEX.
Well, IBEX was before LCROSS.
That's right. So IBEX was an interesting one. So we weren't trying to go to the moon. What we were trying to do is avoid the moon. The moon was messing with our gravity. We were in this big 9-day orbit period, elliptical orbit in cislunar space. And every time the apogee of our orbit got near the moon, we weren't very happy. And I know it's hard to believe, but the scientists who were like, paying for the mission and everything wanted to know where the spacecraft was going to be a couple of years from now. We didn't know because the moon kept messing with the gravity. And so we figured out ways to fly the original 2-year mission. And we were doing Monte Carlo studies to figure out all the possible, using our orbit determination, error, uncertainty, talking like an astrogator now.
Right.
And figure out where we would go. But then for the extended mission, we thought we really, if we want to predict for 10 years, we need to do something. So we ended up going into a lunar resonant orbit. So we locked in the orbit period so we would always miss the moon. So we chose a 3-to-1, it turned out. And then that was just
well, and there's a graphic we
steady.
can show of this if we want to put this up
Yep.
later that shows what the orbit looks like in the Earth-Moon rotating frame before we got resonant and after we got resonant. And before, you can see that the apogees are just kind of clocking around the system, and sometimes they're near the moon and sometimes they're not. After you lock in, then the apogees are always in places that point away from where the moon
it makes
is.
like a 3-leaf clover. Yeah, in the Earth-Moon rotating system, you'll see the Earth is always in the center, the moon's always at the top. The trajectory's in green, and we show the moon's orbit just for scale as the white circle around that, and that just helps us. It's a weird way to look at the orbit, but it tells us what parts of the orbit are close to the moon and what parts are close to the Earth.
Exactly.
So we freeze that Earth-Moon line. So that's super helpful to do that.
You made the joke about that being an astrogator. That is obviously. I think some people know that is an AGI product, but the term actually comes from a science fiction book, meaning a navigator in space.
Yeah. It was Starman Jones was the book by Robert Heinlein.
And we've seen it in other places too. I think that actually in Star Trek they had a device that was called the Astrogator, and I think in Lost in Space they had one as well. They had a physical device. In Heinlein's Starman Jones book, the Astrogator was a person. He was the navigator on board the spacecraft, and there was an Astrogators Guild that you had to be in order to be the navigator. And the whole story was about the Astrogator kid that stowed away on the spacecraft and then saved the day in the end when the real Astrogator
spoiler
was killed
alert.
off.
Yes, and we
exactly.
we do have an Astrogators Guild website.
That's true.
Feel free to
Is
go
that?
there.
I didn't know that was still active. That's great.
It is.
Very
It
active.
is active.
yeah,
Yeah, we
yeah.
try to post kind of like what we're talking about here.
Yeah.
We just try to post things that are of general interest to us, I guess.
That's right. And sometimes we're more prolific about posting than other times.
Yeah.
So now that we've talked about this, we're going to have to run home and post something.
You got to
on it.
post
So
something.
you can post a link to this right
Yeah,
to there.
exactly. That's what.
It's
we'll do.
great.
it'll
Yeah.
be
So
like a
so
recursive.
so that was IBEX. Then there was then we talked about
Then
Laddie,
and
LCROSS,
and then Laddie was after that.
and then Laddie, and then what else was in there? And then
Bereshit.
I guess Bereshit.
Right.
Yeah. So Bereshit was really cool. Well, Mike, you met those guys years ago.
Right. So the Bereshit Space IL team was originally a Google Lunar X Prize competitor, and that had come from a long line of work that other projects we'd worked on, and we worked with several of the other X Prize teams. But Bereshit was the one that persisted and ended up flying, and but we'd known them for some time, for 4 or 5 years before we finally launched that.
And that was super exciting because it's commercial. So this isn't government. How are we going to do things commercially, which is kind of what I always thought we would do, watching the documentary 2001 A Space Odyssey about the future was all commercial, right?
That's super accurate too. I mean,
and so this was really cool to finally see that happen. Yes, we governments have shown they can go to the moon, but a commercial entity can go to the moon as well.
Right.
Yeah.
So you mentioned that movie. What's your favorite space movie then?
So my favorite space movie, mine is The Fifth Element.
Okay.
Yeah.
I probably go with Apollo 13. I mean, it's a realistic, real movie.
Oh,
but-
realistic movie?
Yeah. Well,
It doesn't have to be realistic.
Well, but that's the one that came to mind right away.
Yeah.
Because
Yeah.
just because of my interactions with people the real people that.
Well, you were involved with some of that, and we'll get to that a little bit later.
Right.
Apollo 11 was an amazing movie.
That's pretty good. Yeah, that's a good
Yeah.
movie too. Another one.
Yeah.
That's,
So what's the
Not
one
science
that? What's
fiction.
your least favorite space movie? That the least accurate, or just makes your skin crawl?
Well, there was several. There was 2 Mars movies that came out like back to back years ago. As
the one of them just drove me
what was
crazy.
the Val Kilmer one? What the heck was it?
It's called Mars, I think. Right?
The one where they
If only we
tried
could find
to
out.
do. Yeah. Do you have
Exactly.
any sort of computer device that can search on
Yeah,
things?
exactly.
Let me see.
That was,
I used to work
modem
for a
here.
company that made a search like
it might have been.
I might
like,
call it an engine.
one of them might have been called Red Planet.
Which is the one where they did the Mars orbit insertion with their hands.
Oh, that had.
I did not like that one. That made me cringe.
They just stepped out and like floated across.
Yeah, and they floated across.
Tim Robbins was in it as one of the astronauts. Yeah. I'm trying to think.
And the thing is, there's enough drama in flying real space missions that you don't have to break physics.
Right.
Like the real physics.
Right. Exactly.
Yeah, it's really exciting. And
I can't think of the name of it, but in the one, I believe it's the one with Tim Robbins. They're in the spacecraft and they're on the way to the moon.
Or on the way to Mars.
Right? And they're all in the spacecraft, and there's some kind of tenseness going on, and there's a fight or something. And then all of a sudden, as they're starting, they turn around to do the burn to capture at Mars, and the engine explodes and falls off the back of the spacecraft. And so rather than, since they're screwed because now they haven't captured, they just get out of the spacecraft in their spacesuits and float over to the spacecraft they were going to get into that was in orbit.
Well, the one
Mars.
real
They
part
just like swim over there.
Yeah,
Like
they just float over.
It was a little bit realistic.
Without any braking or anything.
No, the one guy slowed himself down by putting his hands and dragging across the satellite.
That's right.
And he almost didn't have enough satellite. But apparently, there's enough friction there to slow you into.
Well, yeah,
to
it
capture.
reminds you of the Bugs Bunny thing, that Bugs Bunny used to do, where it was like in a house or something, and it's falling towards the ground, and right at the end, he just steps out, and the house is crushed behind him, and he just keeps walking.
Right, you just jump
exactly.
at the last second.
Exactly,
You're okay.
it was just like that. Yeah.
So that's not real.
Oh, it is. It totally
Bugs
is.
Bunny.
It's totally-
Thanks.
But they didn't have Bugs Bunny in the movie, so I didn't believe it.
Okay, right.
Yeah.
So, and we're working on some other lunar missions, and we're. I mean, I don't want to speak for you, but from what we've talked, I think we're both really excited about these commercial lunar payload services that have come out. The new human landing system, HLS stuff. Yeah, it's a cool time to see that lots of people can get to the moon in various ways.
There's commercial landers that are being done to deliver payloads for NASA. Blue Origin just announced their Blue Moon thing the other day. There's the next step stuff going on with human landing systems, and of course Elon Musk's stuff is BFR rocket and Blue Origin. So there's a bunch of things going to the moon, and it's a pretty exciting time to think about lots of those trajectories being flown. And then also John talked about the Space Isle mission. We're working with the South Koreans as well, and in those cases, it's fun to work with those folks because it's a national pride thing for their countries as well. So they're really excited and pumped about getting into that. Whereas we sort of take that for granted here. They want to do it too. So it's exciting to have them participate.
Yeah, that's great that there's so much new moon activity going on. That you guys are involved with a lot of it as well.
Yeah, I mean it's something since we were kids.
Right. Exactly.
We just always wanted. We were supposed to do that in 2001.
Right. Well, that's right.
Just jump on the bus and get up there, right?
That's right.
Yeah.
Exactly.
Awesome. Well, thank you guys very much for coming in today. I think you're going to join us again in another episode shortly.
That'd be great.
So thanks again, and we'll see you next time.
Great.
Cool.
We'll talk
Thanks,
to you
Josh.
soon.
Thanks, everybody.
Bye now.